Hello, good afternoon and good morning, wherever part of the globe you are watching. This again your host, Mike Espina, and welcome to Math Agility Live. This is our platform where students can send in their math homework problems to our social media channels, and we will answer them via Facebook Live every Tuesday and Thursday. That's PST, and Wednesday and Friday, Manila time. So tonight, we will be solving the problems given at the Math Agility Competition 2021 last June 25. So let me share my screen to you for the first problem. So I hope you can see my screen. Okay. All right. So okay, for question number 1, the capacity of an elevator. So this is easy round, and this is the first question. So contestants were asked to solve this problem in 3 minutes. And if they get it right, they would get 1 point. So the capacity of an elevator is 18 people or 2,970 pounds. The capacity will be exceeded if 18 people have weights with a mean greater than 2,970 over 18, so that's 165 pounds. Suppose the people have weights that are normally distributed with a mean of 171 pounds and a standard deviation of 35 pounds. Find the probability that 18 randomly selected people will have a mean that is greater than 165 pounds. So we have the given information. Let me scroll this. So n is equal to 18. So that's the number of information or data that we have. And then let me just try doing this. Let's scroll. Okay, so for n, that's 18, right? And then we have uh, the sample mean at 165. So it's already given in the problem. And then we have the population mean. So we have two means here. One is the sample mean, which is x bar, and then the population mean, which is mu. And it also was given as at 171 pounds. And then we have a standard deviation of 35, which is the population standard deviation. So sigma x bar would be, so this one would be your sample standard deviation. And sigma would be your population standard deviation. And what was given in the problem is the population SD, or population standard deviation, which is sigma, equal to 35 pounds. And then we have, so given the formula sigma over square root of n, we will be able to solve the sample standard deviation. So at 8.24958, so which is this one here. And now we have to compute the standard score, which is z, or your z score. So that's x bar minus mu x bar divided by sigma x bar equals 265. So that's given, minus 171, which is also given. And then the sample standard divided by the sample standard deviation we have computed. So we get a negative 0.72731 as our z-score or standard score. So we're going to use technology to compute the probability. So which is the area from the left side of 164. So this is uh sorry, not 164 but 165, right? This is 165. So for example, the 165 is at the left. So let's say this is 165. So when we compute the probability using this formula here, or the norm dot dist, and then the C score, comma, mean 0, comma 1, which is a standard deviation, and true means cumulative. So it will compute all the areas to the left of 165, and we got it as 0.23352, and that's equivalent also to the probability. So we can also say that is in percentage form, this is 23.352. Oops, percent. So there's a point here, but okay. And and then therefore the area to the right side of 165, so we need to subtract 1. So we know that the sum of this probability density function is equal to 1. So 1 minus uh, the area we computed earlier, which is the left of 165. So this blue area here. So to get the area on the right side of the equation, the right side of the density function, or so that is 0.76648, or in percentage 76.648, or if you round it off to whole number, that is 77%. So that's the answer for easy round question 1. So let's clear this, and let's move to question number 2. So easy round 2. So a tower in the middle of Golden Gate Park in San Francisco, standing on level ground, is due north of the Young Museum and due west of Botanical Garden, a distance c feet from the Young Museum. If the angles of elevation of the top of the tower as measured from the Young Museum and the Botanical Garden are alpha and beta, respectively, find the height h of the tower. So as you can see, we need to draw this first, and if you properly draw it, this would be similar to what you can see on the screen. So H, so this is the De Young Museum here on location A at point A, and then B would be on Botanical Garden, I mean, is in point B here, and this is the tower, right? So it says alpha is the angle from the De Young Museum towards the top of the tower, so this is alpha here, and beta is the angle between the Botanical Garden and the tower, so which is this one here. And the distance between A and B is C, right? So this is a distance C given here in the problem from the De Young Museum to the Botanical Garden. So what we will compute is find the height H. So in the triangle ACD, so let me clear this. So where is triangle ACD? So A, D, so CD. So the triangle on the left hand side, which is also a right triangle, right? We can get the cotangent of alpha, so that's segment AC over H. So segment AC, so if you remember your SOHCAHTOA, so SOHCAHTOA, so sine is opposite over hypotenuse, cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. Since tangent is the inverse of cotangent, so cotangent would simply be your adjacent over opposite. So if your angle is alpha, so adjacent would be AC, right? So this segment here over H, which is the one opposite to angle alpha. So now we got cotangent alpha. So let's now solve for when and in angle BCD. So let's do angle BCD. So cotangent will now getting or deriving the cotangent of beta. So cotangent of beta would be again the same, which is adjacent over opposite. So adjacent to beta to point B is the segment BC, right? This line here. This line is BC, or the segment is BC, and the angle of the side opposite to beta is H. So we have cotangent beta is equal to segment BC or BC over H. Okay, so let's just clear this. Let's move the screen a little bit so you can still see the figure. So in then so we can rename or move the H beside the cotangent, the function. So we will be able to define AC in terms of H and alpha, and BC in terms of H and beta, which is this two equation here. So since ABC, so ABC, so the angle which is here, flat to the ground, we can write the formula, of course, the famous Pythagorean theorem, AC squared. So AC, let me just change the color. So this is AC, this is BC, which we already had defined earlier, and this is C, right? The distance between A and B. So so this is the formula for Pythagorean theorem. So AC squared plus BC squared will be equal to the hypotenuse, which is C squared. And we know that AC is equal to H squared cotangent alpha squared, and BC would be H squared cotangent beta squared. So, and it is equal to C squared. So just manipulating this, you would get this answer. H is equal to C square root of cotangent alpha squared plus cotangent beta squared. Okay, so I have an info statistic. So the first question, I forgot to say this earlier. So from the 14 finalists, only one got the correct answer for problem number one. And this in this problem number two that we had just solved, again, there's only one person who was able to solve this in 3 minutes. So of course, we have to factor in. I know this is easy. This is just a trigonometric problem, but if you're in the finals or if you're in the competitions, you're time pressured and you're thinking, of course. So most of them did not get this one. Okay, that's, I think, that understandable when it's a time pressured task. Okay, so let's clear this, and then let's move to question number three. So E3. So I think this is a calculus problem. Yes. So a camera is placed 3,000 feet from a rocket launching pad. If a rocket is rising vertically at 880 feet per second when it is 4,000 feet in the air, how fast is the camera to rocket distance changing at an instant? So this is a time rates, right? Uh, of course, before we can compute anything like this kind of problem, we have to draw it. So we have the rocket here. So that's 4,000 feet as given in the problem. And the rate that it is rising vertically is at 880 feet per second, right? And then what information do we have here? So a camera is placed 3,000 feet. So this is your camera. So we gonna have a 3,000 feet distance from the rocket. So the rocket is here. So the distance between them is 3,000 feet. And of the distance of the camera to the foot of the launching pad is not changing, of course. So uh, this camera is not moving, and the distance from the foot of the launching pad of the rocket, of course, is also not moving. And then what we're trying to solve is the rate at which the camera to rocket distance is changing. So that is actually the hypotenuse. We name the side C. So we have to know this as well. And the rate at dc/dt is the rate of the camera to rocket distance. So let me just clear this so we can move up. So the relationship can be derived again from the famous Pythagorean theorem to solve for the unknown C, which is the distance of the camera when the rocket is 4,000 feet vertically. So we have again this equation. So C squared equals X squared and plus Y squared. So plugging in our values, so we have X as 3,000. So we plug it in here, and our Y is 4,000. So solving for C, we got 5,000 feet. So we already know C, which is 5,000 feet. Now, let's revert back to the Pythagorean theorem, Pythagorean or the formula that we just have used for solving the side C. And then let's try to get the differentiation with respect to time. So, of course, dc over dt. So bring down 2. So c dc over dt equals 2x dx over dt plus 2y dy over dt. So again, let's move this up. So substituting the values we have for to the equation. And so our C is 5,000. Of course, we can cancel out 2 first. So cancel out these 2 here. This because they are common to both sides of the equation. So and then let's substitute the C, which is 5,000, and dc over dt is the one we're solving. And then x is 3,000. Dx dt is not changing, so it's 0 as we have mentioned earlier. And then y is equal to 4,000, and then the rate the rocket is rising vertically is 880 feet per second, right? So solving for dc/dt is equal to 704 feet per second. So if we revert back to our figure, so this distance here is changing at a rate of 704 feet. So from rocket to our camera changes from 704 feet per second. Okay, so for that problem, actually 4 out of 14 of the finalists got it right. Okay, so let's move now to question number 4. Easy round, still the easy round. E4. So this is a physics mechanics problem. So a horizontal force of 140 Newton is needed to pull a 60 kilogram box across the horizontal floor at a constant speed. What is the coefficient of friction between floor and the box? Determine to 3 significant figures. So again, it is important that we need to draw correctly the free body diagram or FBD. So let's refer to the free body diagram I have drawn here. So, and here are the meaning of all the letters given there. So F would be the horizontal force. So this is the horizontal force. F sub F would be your frictional force, which is this. And then F sub N would be the normal force. And F sub W would be the weight. Okay, so for the forces in the y-axis, uh, which is the vertical axis, right? So the forces acting on that are the weight and the normal force F sub N. And I mean, the weight would be F sub W, and there's no movement up or down. So there's no acceleration. So A sub Y would be 0. So we can have the equation summation of force on Y, or the vertical axis, would be mass times acceleration of Y. So since the only force acting would be the normal force, which is going up, so would be positive, and the weight, which is mg, and it's going down, so this is minus, so that's minus mg. So, and then below equals to 0. So let's move up this a little bit. So we can solve for Fn, right? So, okay, let's put it here so you can still see the drawing. So Fn would be equal to mg here. So what is mass? It's given, so 60 kilogram. And then we know g, which is the gravity, 9.81 meter per second squared. And we have 588.6 Newton here. So now for the x component, so everything that moves left or right, the normal force is equal to the frictional force. So we have summation of fx, max, and since there is constant speed, therefore there is no acceleration. So here we have a constant speed again, a of x along the x-axis would be 0. So F would be 140 Newton minus the frictional force, F of sub F, which is equal to 0. So F of F would be 140 Newton. That's the force. And what we're trying to solve is the coefficient of friction. So it is basically the ratio of the um, frictional force, 140 Newton, divided by the normal force of the one we solved earlier, which is 588.6 Newton, and we got 0.238, and this is unitless, right? Because this is friction. All right, so for this problem, there are actually 7 who got it correct. So 7 out of 14 got it correct, so 50%. Okay, so let's clear this. Okay, let's move to the next problem, which is easy question number 5. So this is a statistics problem. So for each student, can his or her average quiz score for the semester be used to predict his or her final score? So to answer this question, quiz averages and final exam score were recorded for a sample of 100 students who took Calculus 101 at Stanford. The results of the regression analysis are displayed below. So we have the predictor, which is the constant, and quiz average. These are our variables. And then, of course, the coefficient, which is 10.52 for the constant, and quiz average at 0.8524, standard error 15.1, and for 0.4365, t statistics at 0.697, 1.953, and then the p value 0.315, 0.00. So S is 10.8131, and R squared is 47%. R squared adjusted is 45.7. So one student in the class had an average quiz score of 95. If his residual was negative 4.861, what was his actual final exam score? So first is we need to form the regression line. So based on the given coefficient here, we can have our regression line y is equal to 10.52. So this is constant in the regression analysis, right? 10.52. And then we have 8.524. So that is your quiz average. And it's like your slope, right? So 0.854 times the variable x, where x is the quiz score and y is the final exam score. So there's a given quiz score here, which is 95. So if we, okay, let's let's move the screen a little bit up. So we have a 95 given as the average squeeze score, and we now have to compute the fitted value. So y hat, so if you see that little symbol here on top of y, so that is 10.52 times 0.8524 times 95, and we got 91.5 here. And we have the formula, which is the residual. So that's the difference of your actual value y and the fitted value y, or so which is this. So given also the residual, we have negative 0.48, negative 4.861 as given, and we don't know why, right? Which is the actual final exam score of the student we're solving. So, and then we got 91.5 as our fitted value, which is y hat. Therefore, we can solve the student's actual final exam score, which is basically 91.5 minus 4.861. And so the actual final exam score of that student is 86.639. Okay, so for this question, two got it correctly. So 2 out of 14. Okay, so let's move. Okay, so before we will continue with the average problem, we will post for a commercial break. Okay, so let me just stop sharing this.
Kids dread math, but unfortunately, parents are busy juggling responsibilities and are unable to help their kids with their math homework. High school and college students find math to be difficult and need help with their math and advanced math subjects, while working college students don't even have enough time to study for their math homework. It all boils down to the fact that to ensure continuous success for students in their mathematical study, getting the right help is most important. Unfortunately, current solutions only deliver hours of math preps without spaces for students to even ask their troubling questions. We understand the flaws of these methods, and we've crafted a new solution that works for all students, even low-class junior students. Introducing the Math Agility Math Express 10, Math Express 20, Agile Max 15, and Agile Max 30. The simple but effective solutions to help students through their math difficulties and homework. At Math Agility, we are focused on providing quality tutorials and test preparations to increase the confidence of students with math concepts and problem solving. And with each subscription package, every student gets to enjoy access to math support like never before. The Math Express 10 allows students to ask 10 questions, valid for 7 days. The Math Express 20 allows students to ask 20 questions, valid for 30 days. The Agile Max 15 allows students to ask 15 math questions weekly, while the Agile Max 30 allows students to ask 30 math questions monthly. Now, busy parents can worry less knowing their kids have the best math help while in high school. College students and working college students can get the help they need with their homework. Getting started is easy. Simply create an account, log in, choose a subscription package, pay, and that's it. Start asking your math questions and get the help you need. Visit www.math-agility.com.
Okay, welcome back. So to continue with our solving the average round problems. If you have any questions on the problems we solved earlier, For the easy round, you can type in your question on the comment section of our social media accounts, and we will answer them as soon as possible. Okay, or after this live session. Okay, so let's move to the average question. So let me share again my screen. So for average question, uh, again, there are five problems, and then this is 2 points each. And they have contestants are required to solve this within 4 minutes. Okay, so the first question is again another physics problem, mechanics problem. So in the figure, two blocks have identical masses of 50 kilograms. Both experience a sliding friction force with mu sub k, which is 0.25. Find the tension in the tie cord. So this is the tie cord here, right? So again, the key here is that you will be able to draw the free body diagram. So let's start first with mass A or body, the block A, as you can see here on the left side. So uh, F of t should be going to the right direction, and the frictional force of A would be going to the left direction. And then towards up would be your normal force on A, and the weight, of course, is going down, F sub WA. So this is the free diagram for block A. And then for block B, we have, of course, the normal force B going up, and the weight of this body B, which is M, or block B, is uh, WFB, F sub WB, and we have to get the components of this, which is, we know that is 30 degrees down and right side. So which is given here, right? So we know that this is 30 degrees. So mg cosine 30 degrees would be the component going down, and mg sine 30 degrees would be component going to the right direction, because this is your angle right here. So adjacent would be your cosine, and your opposite would be here, which is equivalent to this force here, mg, which is the sine 30 degrees. And then we still have two forces. So the ft, which is the force on the tie cord, and which is also the same direction of the frictional force on B, right? So now we draw both the body diagrams of block A and block B. So let me clear this and let's move this up. So computing the frictional force on blocks A and B by using the formula F of n, so equals mu F sub n, we have, so for frictional force A, we have 0.25 mg and 0.25 cosine 30 degrees mg. So that's for FB. So the one towards, okay, let me just pull the here. So 0.85 times cosine 30 degrees mg going down. So since mass m is equal to 50 kilograms, and substituting in the equation we have, so if we substitute this here, both equation, we will have frictional force on A is 122.63 newtons. Frictional force on B would be 106.20 newtons. So taking the forces on the x-axis to each of the block by using the formula summation of F of sub x, equals m a sub x, and and using the sign convention where positive x axis is positive, we have ft minus the tie on the cord, right? That's the force on tie on the cord, minus 122.63, which is your frictional force on A. This one is equal to max, so 50 kilogram times the acceleration A. So since we know that ft is equal to sine 30 degrees mg, and minus ft minus 106.20 is equal to 50 kilogram times A. So we have two equations. This is our first equation here. And the second equation is the one acting on the x-axis, which is on block P. So we have these two forces, right? So that's the two negative here. And this is the positive side here. So equation 2 would be equal to 139.05 Newton minus the force on the tie cord, just Ft, the tension on the cord, is equal to 50 kilograms times A. So if we solve equation 1 and 2 simultaneously, we will have, okay, let me just move again the page. We will have 139.05 Newton minus 122.63 Newton equal to 100 kilograms times A, which is equal to the acceleration 0.16 meter per second squared, right? This one. So therefore, from equation 1, if we substitute this value in equation 1, this is equation 1 here, we will get the force, the tensional force or tension is equal to 130.84 Newton. Okay, so we just move 122 on the right hand side and then substitute the value of our acceleration here, and then you will get the force on the tension in the cord. So for average question number 1, um actually none get it correctly, so 0 over 14. So let's move to average question number 2. Okay, so for average question number 2, this is again a statistics problem. So while at the meeting, Roddy asked Lenny to estimate the population mean mu of their experiment with the following sample. So these are your sample 3, 6. So we have 12 samples here. Lenny believes the population is normally distributed. Find the 95% confidence interval for the population mean. Use your use in your answer an open interval or parenthesis accurate to 2 decimal places. So the population is normally distributed as given, and the population standard deviation sigma is unknown. Therefore, we will be using the t distribution in this case here. So given the table, we can compute the sample mean. Sample mean is, of course, is the same as the average. So sum this up. We sum up all the values of our data, and then we divide it by the number of the elements, which is 12. So we know that this n is equal to 12, and divide it by 12, and then we will get the sample mean as x bar equals 14.417. So now let's compute the sample standard deviation. So the formula for sample standard deviation is the square root of the summation of the difference of x sub I, which is your sample, minus the mean, the sample mean, which we have computed, right? This one. And then take the square of that and divide everything by n minus 1. Because we're taking sample standard deviation, so uh, the divisor should be n minus 1. If it's a population standard deviation, we just divide it by n. So subtracting each of the difference of each of the element to our sample mean, So for example, for the first data or the first sample, we have 14 minus our sample mean and then square it. So this is our data 1. This is our sample mean, right? And then square it. So the next would be this is your data 2 or sample 2. And then again, subtract with the sample mean and then square it. So continue it until you have reached the final data 12, right? Again, minus the sample mean and square it. And then that's divided by 12 minus 1 and then take the square root. So we already have the answer for the sample standard deviation at 2.314. Okay, which is this. So with the 95% confidence interval, we can calculate the t statistics using Excel. So I'm using technology again. So t is t inverse 97.5%, comma 11. So this is 11 is actually your degrees of freedom, df. df is n minus 1. So if we have a sample data of 12 minus 1, so we got 11 here, right? And then we have our t statistics at 2.201 here. So to formulate the confidence interval, so this is the equation or the formula. So Ci is equal to x bar plus or minus t s, which is the sample standard deviation divided by the square root of n. So let me just scroll it up. So we know that our mean sample mean is 14.407 and we have already computed our t statistics, which is 2.201, and of course the standard sample standard deviation at 2.314, and our n is 12 here. So our answer should be, so 12.95 is taken from 14.417 minus 1.4704. So you will get 12.95. So that's the first value of the interval. And the second interval would be 0.417 plus 1.4707. 4. This is 4, sorry. Which we get 15.89. So that's our value for the second number here, or the second interval. Okay, so for question number 2, again, no one got it correctly. So 0/14 for this question. So now let's move to average question number 3. So average question number 3 is about sets. Okay. Okay, Nielsen conducted a survey for 120 individuals and have gathered the following information. So 65 read In Search of Lost Time by Marcel Proust, and then 45 read Ulysses by James Joyce, 42 read Don Quixote by Miguel de Cervantes, 20 read both In Search of Lost Time and Ulysses, 25 read both In Search of Lost Time and Don Quixote, 15 read both Ulysses and Don Quixote, 8 read all of the three books. So the question is, find the number of individuals who read exactly one book. So let I, U, and D denote the set of individuals who read In Search of Lost Time. So these are variables. I, this would be U, and this is D, respectively. So we will use the inclusion exclusion principle. So the number of the unions of I, U, union of U, union of D is equal to the number of I plus N of U plus N of D minus the intersection of I and U minus the intersection of I and D, and minus the intersection of U and D, plus the intersection of I, U, and D. So we know that the number of I, n of I is 65, which is this given here. And then number of U is 45 here. And n of D, which is 42 here. And then the intersection of I and U, which so this means they both read In Search of Lost Time and Ulysses. So that is 20. And then intersection of I and D, which is 25 here. And then intersection of U and D, which is 15. Okay. And then the intersection plus the intersection of uh, all of the three books given also 8. So plus 8 here. And that is equal to 100. So we already solved N, union of U, union of D. So let's move the, let's scroll it up. So now since there are 8 individuals who read all the three books, so 20 minus 8 is 12. So these are the people who read In Search of Lost Time and Ulysses, but not all the three books. And then 25 minus 8, so they read In Search of Lost Time and Don Quixote, but not all three books. And then 15 minus 8, which is 7, read Ulysses and Don Quixote, but not all three books. So 65 minus 12 minus 8 minus 17 would read only In Search of Lost Time, right? And then 45 minus 12 minus 8 minus 7 would read or equals to 18, read only Ulysses. And 42 minus 17 minus 8 minus 7 would equals 10, which people who only read Don Quixote. So 120 minus 100 is equal to 20, read no books at all, right? So it's, I think 120 is given. Yeah, so those are given. And therefore, the people who read exactly one book would be this information here. So 28, 18, and 10. So sum it up. So 56 only read exactly one book. Okay, for this question, actually 6 got it correctly. So 6 out of 14. All right, so let's move to, okay, let's clear this. Let's move to question number 4, A4. So this is the problem. This is an optimization problem. So the area of a parking lot is 600 square meters. A car requires 6 square meters of space and a bus requires 30 square meters. The attendant can handle only 60 vehicles. If a car is charged $3 and a bus is charged $8, find how many of each type of vehicle should be accepted to maximize income. So we let X equal to the number of cars and Y be the number of buses. So our objective functions is, of course, in terms of maximizing income. So that's 3X. So $3 times X and $8 times Y. So we have that objective function. And our constraint is, so in terms of the area allotment, so 6X, so that's for the car, and 30Y for the buses. And we only have a limited parking lot of 600 square meters, so it should be less than or equal to 600 here. And then there's another constraint. So the attendant can only handle 60 vehicles. So if we sum up the number of cars and vehicles, it should be less than or equal to 60 here. So of course, our natural constraints should be X is greater than or equal to 0. Cannot be 0. It can be 0, sorry, but not lower than 0. And Y is greater than or equal to 0. So let's scroll it up. I used a graph graphical solution for this. So I have my vertices at 50, 10 here. Let me change the color. So I have 50, 10. The next vertex is 96 and 36 here. And then, of course, I have my 0, 0 and negative 114 and 42.85. So uh, if we get all of the values of these vertices by substituting um, in our objective function of maximizing income. So for vertex negative 114 and 42, we have an income of 0.01 here. And then for 5010, for vertex 5010, we have an income of 230 here. And then for 96 and 36, we have a zero income. Of course, for 0, 0, that would be also zero. So, of course, our X or our cars should be at 50 and our buses should be at 10 to have the maximum income of 230. So, the answer should be 50 cars and 10 buses. So, for question number 4, we have 9 of the finalists got it correctly. So, 9 out of 14. Okay, so let's move now to question number 5 for the average round. So, okay, so um, this is the question. Find the roots of the quadratic equation 2k plus 2x squared plus 4 minus 4kx plus k minus 2 equals 0 has roots which are reciprocals of each other. So, by inspection, we know the coefficients are the following. So, a equals 2k plus 2. So, I'm referring to here to the standard equation of a quadratic, which is ax squared plus bx plus z equals 0. So this is what I'm saying. A is equal to this part here, the numerical coefficient, or the coefficient of x squared, or of the second degree x. And then b would be 4 minus k, which is this part here, in front of x, so the coefficient of x. And then your c, which is equal to k minus 2. All right, so if we let r and 1 over r as the roots of this equation, because it's given they are reciprocal of each other, getting the product will be equal to 1. So getting the product of the two roots is equal to 1 here. And the formula for the product of root is P is equal to C over A. So NRC is equal to K minus 2, substituting this. So this is just the formula. And then RA is 2K plus 2 here. So equating the product to 1, right? Because we know that the roots are equal to 1 as solved here. We got K is equal to negative 4. So if we substitute negative 4 to the equation, to the quadratic equation, this would be the solution. So negative 6x squared. So after we substitute k negative 4 to the original quadratic equation, we have the quadratic equation negative 6x squared plus 20x minus 6 equals 0. So, and then we can factor this out. Factoring out negative 2, we have 3x squared minus 10x plus 3 is equal to 0. Therefore, this is factorable. And we get 3x minus 1, the first um, factor, and x minus 3, which is the second factor. Therefore, we have x sub 1. The first root is 1/3, and the second root is equal to 3. So that is question number 5. Right? Is it? Yes, question number 5. And Actually, 7 out of 14. So 50% got it correct from the finalists. Right. So before we continue our difficult round questions, so let's have again a break, and we will get back again and solve the difficult round questions.
If you are weak in math or have less time studying because of work, then Agile Max and Math Express will be immensely helpful for you. Using Agile Max and Math Express is something easier, and you have to follow these steps. For creating an account, log in to www.math-agility.com. Click the icon on the top right corner. There will be an option available for creating account. After clicking the Create Account, this page will appear. You have to fill all the details like first name, etc. Check the box I am not a robot and then click Submit. You will receive an email about account confirmation. For existing customers, first click the icon to log in, input your details. You will see an option of subscription and click Subscription to choose the package that will fit your needs. The subscription package will show different variants of Math Express and Agile Max. Click Buy Now of the product you want to purchase, and then click View Cart, and then click the Checkout. After this, input your billing address and click Continue to Payment. Choose Payment Method and then click Pay Now. Click Math Agility to go back to your account page, or click Continue Shopping to buy more. For updating the Student Dashboard profile, click the Student Dashboard and fill up your information. Asking math questions by students. To ask math questions, click the Ask Questions and choose your subject. You can type your question and can attach a file. You can view your posted questions in the question list and the remaining unused questions. When you click View from the question list, this page will appear. The math experts from Math Agility can see the questions and can reply with a solution. When students click View, they will see this page. If the student is satisfied with the solution, then they can click on the Close Questions.
All right, we're back. And now we're gonna solve. So if you have any questions from the problem we solved for easy round and average question rounds from the recently concluded Math Agility Competition 2021, you can write it down on our comment section below and we will try to answer them. Okay, so again, let me share my screen to you so we can solve the difficult round problems. Okay, so for the difficult round, so there are again 5 problems. This now uh, is 4 points each if they get it correctly. And they have only 5 minutes to solve this problem. So this is the first question. I gave this question because they're already familiar with it. This was given during the semifinals round. So and it says here in the figure below, inside the square, there are 4 equilateral triangles. Uh, each each triangle having a side of having a side lying on the square and such that each triangle has a side length m. So where m is defined below. So this is a trigonometric function cosine x plus sine x over cosine x minus sine x. And if you notice, it keeps on repeating, but the signs are alternating, right? Here, minus, plus, minus. So it's plus, minus, plus, minus. Also, the third vertices of the triangles meet at the center of the square. So this is the center. This is the equilateral triangle here. And this is M as given, right? Um, the region inside the square but outside the triangle is shaded in pink. So this pink area here, what is the area of the pink shaded region? So that's the question. So we need to find the area of the shaded pink region. So initially, we need to compute the height of the triangle and double it to get the length of the square. So 2h will be length of the square by referring to the figure of the triangle below. So for one of the equilateral triangles, so this would be your h, the side would be m, and of course if you divide it by 2, m over 2, right? So in order to compute this easily, we need to transform the trigonometric identity to a simple form. So let us consider the first two terms of m, which is one positive and one negative. So this is equal to, so if we combine these two, this would be equal to quantity cosine x plus sine x squared minus cosine x minus sine x squared all over cosine x minus sine x quantity cosine x plus sine x, which is the denominator. So manipulating this, we have uh, and expanding all our quadratic in the numerator, we have cosine squared x. So let me just scroll it up so you can see it better. So cosine squared x plus 2 sine x cosine x, the middle term, and then sine squared x. So similar to uh, again to cosine x minus sine x squared when we expand this. So this is cosine squared x plus 2 sine x cosine x plus sine squared x, and combining the the factors in the denominator, we have cosine squared x minus sine x. So if you notice, this would be canceled out. And of course, cosine squared will be canceled out. And we have four. Oh, this should be negative, sorry. So it should not be clear. Hold on. So this should be negative because we have a negative here, right? And this would add up. So 2 sine x cosine x. So negative, negative would be positive 4 sine x cosine x. So what was canceled out was your quadratics, right? The second degree cosine and sine here. But what remains is the sum of 2 sine x cosine x, which gives us 4 sine x cosine x here, right? And then, of course, cosine x squared minus sine squared x in the denominator. And we know that cosine squared x minus sine squared x is equal to cosine 2x. This is a double angle formula. Similar to this, it's a double angle formula, 2 sine 2x. So this means this is equal to, so sine 2x over cosine 2x is tangent 2x. So we already know that the first two terms of m is equal to 2 tangent 2x. Since we have four terms, or we just need to double this for to accommodate or to account for the third and fourth terms of m. So m should be 2 times 2 tangent 2x equals 4 tangent 2x. So our m is 4 tangent 2x. So to get m over 2, that's 2 tangent 2x. So computing the height of our Pythagorean using Pythagorean theorem, so h would be quantity of 4 tangent 2x squared minus 2 tangent 2x squared, right? So if you remember your h in the, let me clear this. So this drawing here, right? H, M, and M over 2. So we're just solving H, right? So this is the value we inputted in the Pythagorean theorem, and this is our triangle here. And so we got 2 square root of 3 tangent 2x as our answer. So we need to double the value of h in order to get the length of the square. So if we go back again to the drawing, this triangle is just half of the square, right? So this part here is just h, and therefore this is also h. So if we combine these two, this would be 2h, or twice of h. So that's why I mentioned it. We have to double it. So the length would now be equal to 2h equals to 2 times the quantity 2 square root of 3 tangent to x. So that is 4 square root of 3 tangent to x here. So to compute for the area of the pink shaded region, we need to compute the area of the square and subtract the area of the four triangles. So now that we know the length of the side of the square, so area of the square would just be length squared. So this is the length that we already solved. So squaring it, we get 48 tangent squared to x. And now let's solve for the triangle. So that's square root of 3 times 4 m squared equals square root of 3 over 4. 4 tangent squared to x. Hold on. So what is m squared? 4 tangent to x. Yeah. So 4 tangent to x squared. So that is 4 square root of 3 tangent squared x. And therefore the area of the pink shaded region. So we have to subtract 48 tangent squared to x here. And since there are four triangles inside the square, we have to multiply 4 to this value here. And our final answer should be 16 tangent squared 2x, quantity 3 minus square root of 3. So for the difficult question number 1, actually 3 out of 14. So 3 finalists got it correct. 3 out of 14. So let's move now to question D2. So just clear this again. So I think this is a discrete mathematics question. So let S be the following equivalent relation on the set C equals 1, 2, 3, 4, 5, 6. So S is 1 of 1, 1, 1, 1, 5, 2, 2, 2, 3, 2, 6, 3, 2, 3, 3, 3, 6, 4, 4, 4, 5, 1, 5, 5, 6, 2, 6, 3, and 6, 6. So the question is find the partition of C induced by S. So we are required to find the partition of C that is induced by S. It is similar as finding the equivalence classes of S. So those elements related to 1, so which are 1 and 5, right? So change my, so element 1 related to 1 and 5. Why? Look at the S, which is 1, 1, and 1, 5. So now, then we can select an element which does not belong to 1. So which is 2, right? So we can choose 2. The elements related to 2 are 2, 3, and 6. So if you look at 2, 2, 2, 3, and 2, 6. So we have 2, 3, 6 here as related to 2, the element 2. Now, the only element which does not belong to 1 or 2 is 4. So 4, and also the only element related to 4 is 4. So 4 related to 4 is 4. and 4 is does not belong to 1 or 2, right? So 2, we have relation with the elements 2, 3, and 6, while 1 has an relation to the element 1 and 5. So now we know that the partition of C induced by S would be the first bracket. Okay, so base 1 comma 5, which is the first one, first partition. Second partition would be the base 2 comma 3 comma 6, which is the one we computed here. And the last one would be base 4. So these are the partition of C induced by S. So for question D2, 3 got it correctly. 3 out of 14 got it right. So let's move to question D3. So question D3 is another statistics problem. So find the moment generating function of a random variable x that is binomially distributed. So this is the density function f of x, p, x, capital X equals x, which is our random variable, is equal to n taken x at a time. So that's why I wrote it here in the question. And p to the x q n minus x. So given that with a random variable capital X that is binomially distributed, the density function is this, right? Given. So the moment generating function formula is given by m of t expectation of e to the tx, which is also equivalent to the summation of e to the tx f of x. And f of x is our density function, which is given. So we can just plug it in with our summation equation. And we can just rearrange this, combining e to the tx and px, which is this. So quantity of p e to the t close quantity x q n minus x plus the n taken x at a time from x equals 0 to n, right? So we also know that n x taken at a time is equal to n factorial over x factorial n minus x factorial, right? So if we expand the summation equation from 0 to n, so let's see what will be the pattern. So let's try using x equals 0. So that means n 0, right? So this would be equivalent to n factorial over 0 factorial n minus 0 factorial p e to the t quantity 0 q n minus 0. If you are able to manipulate this, we will get q to the n. So if we try x equals 1, so that means n1. So that is n factorial over 1 factorial, quantity n minus 1 factorial, pe to the t, and then the exponent as 1 because x equals 1, and then q n minus 1. So the answer should be n p e to the t. So we don't need to write 1 here, right? And then we have q n minus 1. Now for x equals 2, we have n minus 1 over 2 p e to the t squared n minus 2, right? And then if we continue it up to x equals n here, so that means n is to n. So substituting again to our formula, n factorial minus n factorial, p e to the t raised to the n, q n minus n. So n minus n factorial is actually 0 factorial. But 0 factorial is equal to 1. So we have 1 here at the numerator. And this cancels out, right? And q n to the n. So q n minus n is q to the 0. Again, q, any number raised to 0, any variable raised to 0 is equal to 1. So this is equivalent to 1. So what is left is p e to the n, p e to the t, quantity raised to the n here. So let's sum this up. So if we sum up MT is equal to, of course, the first term, the second term, the third term, and the last term, we notice that this is an expansion raised to the n of Q plus E P e to the T, right? So um, for this particular question, 2 actually got it correctly. So 2 out of 14 got it right. Okay, let's move now to the next question, which is D4. Okay, so let's move to difficult round number 4. So let S be the surface 2x squared z plus xy squared plus 2yz equals 74 in R to the 3, which is does mean it means three variables or three uh, dimension xyz. Find the tangent plane h to s at the point P234. So I actually edited this because uh, the problem given in the actual finals, I had a correction here. I think I put some like 158. So uh, if you actually substitute 234 on that previous equation, it's not part of the surface, so it does not touch the plane or the curve, I mean. So I edited this already, and so using the formula for the normal vector to a surface f of x, y, and z is equal to 0. So n, the normal of x, y, z is equal to f sub xi, f sub y, j, plus f sub z, k. So this means these are partial derivatives with respect to the given sub variable. So if it's f sub x, so that means partial derivative of f with respect to x. So if we take the partial derivative of f of x, so we have 4xz plus y squared, and then partial derivative of f with respect to y, which is equal to 2xy plus 2z, and then partial derivative of f with respect to z, so 2x squared plus 2y. So for the normal vector, f of xi plus fyj plus f sub zk, we have this. So let me just scroll it up. The normal to the surface S at point P is at n of 2, 3, 4. So simply substitute all of our partial derivatives and at point 2, 3, 4. So again, substitute. So x would be 2, y is 3, and z is 4. So we have 41i, 20j plus 14k. So the equation of H has the form 41x plus 20y plus 14z equals to c. So we have to find the value of c by again substituting the point P, which is P 2, 3, and 4. So solving for c by substituting in this equation H, we have c is equal to 198. Therefore, the tangent plane H to S at point P is 41x plus 20y plus 14z equals 198. So, okay, so let's move to question number 5. So, okay, let me scroll this again. So, this is the problem. So, find the value of P so that the equation in Y has 4 real roots in arithmetic progression. Y to the fourth minus 1 plus 4p y squared plus p squared equals 0. So assuming that r and negative r are the roots, so we assume this, then the arithmetic progression with difference of successive term d equals 2 will be, so negative 3r minus r, and then 3r. So those are the roots in arithmetic progression. So if we substitute that in our since we know that these are the roots, so basically that's why plus 3r, y plus r, y minus r, and y minus 3r is equal to, again, what is given as our not quadratic, but our equation to the fourth degree, which is this. So let's rearrange our roots. So y plus 3r, y minus 3r, y plus r, and y minus r. So that is equivalent to y squared minus 9r squared, quantity y squared minus r squared. And of course, again, it's still the same on the right-hand side of the equation. So expanding our left-hand side, this would give us y to the fourth minus 10r squared y squared plus 9r to the fourth, and again, equivalent to similar to the right-hand side. So again, the equating coefficients, we can see that y fourth, 10r squared is equal to 1 plus 4p, 1 plus 4p, right? So, okay, so 10, since these are both negative, so we just cancel out the negative. So 10r squared plus 1 for p, and then 9r to the fourth is equal to p squared. So that's equation 1 and 2. So from equation 1, we have, if we move 10 to the right hand side, so we have r squared is equal to 1 plus 4p over 10. That's equation 3. And then let's all substitute equation 3 to equation 2. So let's move a little bit. Let's scroll this up. So if we substitute 3 to 2, we have 9, quantity 1 plus 4p over 10 squared, because this is only r squared and this is r to the fourth. So we're trying to substitute r squared to equation 2. I mean equation 3 to equation 2. So p squareds will remain the same. Expanding, of course, 1 plus 4p, we have 1 plus 8p plus 16p squared over 100. And then distributing 9. And of course, multiplying 100 to the right hand side. So we have 9 plus 72p plus 144p squared equals 100p squared. Um, and this would now be equivalent to 44p squared plus 72p plus 9 equals 0. If we simplify this, so factoring, we have 22p plus 3, quantity 2p plus 3 equals 0. So therefore, the value of our p is equal to negative 3 over 22, and p is equal to negative 3 over 2. So this is just 22p plus 3 equals 0. So negative 3, 22p divided by 22. So this would be p equals to negative 3 over 22. So similar to 2p plus 3 equals 0. So 2p equals negative 3. P is equal to negative 3 over 2. So those are our two answers for the value or the values of p. All right. So for this question, actually one got it correct. 1 out of 14 got it correctly. So, okay, that's it. So this is difficult question number 5 already. So if you have any question, just write down on our comment section below. And of course, before closing this episode, I would like to again congratulate our our winners. So let me just share again the screen. So these are winners in order. So rank 1, so it's Sefi Mars Teklikan, and he got a $400 as his prize. And then rank 2 is MC Noriel Baldonado, and he wins $200 as his prize. Rank 3 is Gerald Adorna. So he got $100 as his prize. And then for rank 4 up to rank 6, they got 20 1,000 pesos or 1,000 load. So rank 4 is Mansur Aguas, rank 5 is Sander Banyaga, and then rank 6 is Joshua Milo Hugo. And then from rank 7 to rank 10, they got a 500 cash or load. So it's Chris Norman Algo for rank 7. Rank 8 is Aljon Tomeldan. Rank 9 is J. Lord de Vera. And then rank 10 is Jean Callejo. And then for rank 11 to 14, so they got a 300 pesos mobile load. So that's Kyle. For rank 11, Kyle Beton de Doro. And then rank 12 is Ronald Munoz. And then rank 13, it's Kate Lucero. And rank 14, that's Ivan James Lorenzo. So again, congratulations to these 14 finalists. And I think we're done for today. If you have any questions regarding the problem we solved today, you can again write down your questions or send into our inbox or chat box in all of our social media accounts. And we will see you again to the Math Agility Competition 2022. So that will be next year. We will provide all the details, hopefully early March of next year, if you will be joined. So from today up to the March, try learning and try to dig up all the questions that we have given to this competition so you are prepared for next year's competition. So there you go. Thank you very much for watching Math Agility Live today. And please also follow us in our YouTube channel to watch the replay of this episode. So see you next time. God bless everyone and stay safe.